All right, here we go, everybody. Review for the Unit 2 test. It is a test. It's 100 points. The beginning part of the test is without the calculator. It is not multiple choice like you see here, but I just wanted to do something quick to review the review roots and how the powers cause the roots to work. Also, just some things with degree and behavior, stuff like that. So just real quick, if you look at this one, you have a degree of 1, 2 more, that's 3, and 1 more. So we have a degree of 5. I'm sorry, degree of 4. Sorry. So the degree is 4, but it's negative. So even and negative mean that both ends are going to point down. So right away, you're down to either C or D. So your roots are x equals negative 3, x equals negative 1, and x equals 2. Well, both of these have the same roots. It's going to bounce at negative 1. This particular one bounces at positive 1, and this one bounces at negative 1. So I would guess that, venture to say that C is the graph of that one. It's not multiple choice, but you will have to draw it. So it's really more like this one. So again, the degree, let's go back through this. You're just adding up the powers. This first one has a degree of 1. So our first root, which is 0, that has a power of 1. So we're going to have 1 plus 2 plus 3. So we have a degree of 6. Turning points is 1 less than that. So a number of turning points would be 5. Y-intercept, remember you won't have the calculator. So you're going to have to put 0 in there for all the x's. So we have 0 times 0 minus 2 squared times 0 plus 1 to the third. So this is going to be 0 times 4 times 1, which of course is 0. So we have a y-intercept at 0. To find the zeros, you take all the factors and set them equal to 0. You can do that in your head probably. You're going to have x equals 0, x equals 2, and x equals negative 1. And so I'm going to put these on my graph. Of course, our 0 is already there. X equals 2, x equals negative 1. Now, we do have some behaviors around these roots. The negative 1, this is going to slide, and the 2 is going to bounce. So remember that when I go to draw it. The end behavior, it is even and it's positive, so we know that as x goes to infinity, y is going to infinity. As x goes to negative infinity, y is going to infinity. So both ends are going up. So we know that both ends are up. It would probably be smart to count by 1/2 going left and right, because these are all GM'd up, but we'll deal with it the way it is. Now we do have some question as to what happens in through here at x equals 1. It doesn't say to find additional points, so you can guess if you'd like. And so it's going to come down here. We really don't know what's happening. At 2 it bounces. So I got to make it bounce. Forgot about that. So let me fix my graph. Here's 0. I'm going to change this so that I can count better, so that the graph looks better. So I'm going to have a 2, a negative 1, and a 0. And so at 2 it's going to bounce. So it is going to come up here. Now on the answers, I actually figured it out and figured out what's happening at 1. So because I just wanted to know. So to figure out what's happening at 1, you plug a 1 in to the original function. So we get 1 times negative 1 squared times 1 plus 1 to the third. So that's 8. This is 2 to the third. So we have 1 times 1 times 8. So at 1 it does go up to 8. So it does go all the way up there. Now, you do not have to do this. This is optional. But I just wondered. At 0, it's going to go straight through. At 1/2, I have no idea what it's doing. And then at negative 1, it's supposed to slide. So do your best in drawing a slide. All right, still without the calculator, your horizontal asymptote is to take your lead coefficients, which these of course are x squared and x squared, so we get y equals x squared over x squared. They have the same degree, so you could reduce that and you get y equals 1. Vertical asymptote sets your denominator equal to 0, but of course you should factor this to figure out if you have any holes or anything. You always want to do that before you start answering some questions. So we have x plus 5, x minus 5 on the bottom, and on the top looks like it's going to be x plus 5 and x minus 1. So we do have a hole at x equals negative 5, right? You take your factor, set it equal to 0. So x equals negative 5 is where the hole is. So if it's a hole, it can't be a vertical asymptote. So we do not have two vertical asymptotes. We only have one vertical asymptote, denominator equal to 0. So your vertical asymptote as x equals 5. Now for the rest of the test, you can use the calculator. Finding all the zeros means do whatever it takes. If you can't factor it, use the quadratic formula. Imaginaries, radicals, fractions, all of these are good answers. This is the difference of two squares. Set that equal to 0, x minus 4x plus 4. You could keep factoring it, or you can set each factor equal to 0. X squared equals 4. We get x equals plus or minus 2. Here we get x squared equals negative 4. And when you take the square root of that, we get plus or minus 2i. Number 12, you're going to factor by grouping. You're going to split it up right down the middle. So they first two have an x squared in common. This leaves you with 2x minus 1. Second two have just a 4 in common, leaves you with 2x minus 1. Of course, the whole thing equals 0. Taking out the common factor, 2x minus 1 leaves you with x squared plus 4. When you set each factor equal to 0, here we're going to get x equals 1/2. Here we get x squared equals negative 4, just like the problem before it, so we get plus or minus 2i. And for number 13, it's a trinomial. Set it equal to 0, x squared and x squared. Multiply to get 14, difference of 5, so negative 7, positive 2. So x squared plus 2 equals 0, x squared minus 7 equals 0. When you take the square root of negative 2, the imaginary comes out. It's I plus or minus radical 2. Over here we get x squared equals 7. It's not imaginary. It's just plus or minus radical 7. Now the directions for number 14 are not all the way right. The directions on the test say write a polynomial in standard form. So you know if you have one imaginary, they always come in pairs, conjugate pairs, which is a fancy way of saying that the imaginary parts are opposite. So we have x minus 5i and x plus 5i. We also get x minus I and x plus I. I would suggest doing the ones that are the same but opposite signs, because they're difference of two squares. I would suggest pairing them up that way, the 5's and the i's. So then when we do this, you're going to get x squared. Now you know that the outside and the inside are going to cancel. Then you take negative 5i times positive 5i. This is negative 25i squared. Now I'm going to do these two together. X squared, outside and inside cancel, and then we're left with minus I squared. I squared equals negative 1, so we have to take that out. So when we plug in a negative 1 right here, and we plug in a negative 1 right here, you can see that it changes. Makes this x squared plus 25 times x squared, these two signs right here, plus 1. Now we're going to multiply that together. You can make the box, if you like the box, and do it that way. or you can just use FOIL, whatever works for you. We get x to the fourth. Outside is x squared. These two right here together is 25x squared, and then the last two is plus 25. So we add up the 1 and the 25, we have x to the fourth plus 26x squared plus 25. For the inequalities, it's got to be set equal to 0 first. X to the third minus x squared minus 4x plus 4 equals 0. So this is factor by grouping. Take out the x squared. And then, of course, this second part, this starts with a negative 4, so you got to take that out. This is not a fraction, as you can see, so we're just straight up solving it. All the answers we get will be put on the number line. X squared minus 4 times x minus 1. So we get x squared equals 4, x equals 1, plus or minus 2. On your number line, please put these in order. Negative 2, positive 1, positive 2. Pick a section of your number line to test. Please make sure that your number is in the correct location. Like, for example, x equals 0 is not over here, so don't do that. I am going to test 0, which lives right in here. When I put that back in, I'm going to put it into the original problem. This is 0 minus 0. Is that greater than 0 minus 4? So I have 0. Is that greater than negative 4? That's, of course, a yes. Now, in the original problem, there was no line under the symbol, so these are all open. They all follow the same rule. Line under it, they all closed. No line, they're all open. So this is a yes, no, yes. Please, please, please put your answer in interval notation. This is going to be negative 2 to 1 joined up with 2 to infinity. Now for number 16, this one is a fraction, as you can see, and the fraction behaves differently. We have different rules. The numerator is going to go with the top sign, and the denominator is never equal to 0. So you treat them separately. So we're going to have 2x to the third minus 4x, set that equal to 0. Factor it out. Please make sure you take all of your factors, set them equal to 0. So here we get x equals 0 because you divide by 2. Here we get x squared equals 2. We're going to have x equals plus or minus radical 2. You'll have a calculator, so you'll have to get the decimal of that one. Now we're going to take the denominator, 3x to the third plus 4x squared, set that equal to 0. You take out what they have in common, which is x squared, leaves you with 3x plus 4. Now when you do this, we get x squared equals 0, so we get x equals 0. We also have 3x plus 4 equals 0. Now in terms of what's happening with this, if you think about our numerator and our denominator, 2x times x squared minus 2, and the denominator was x squared times 3x plus 4. We do have a whole, because this cancels. So this is kind of a weird problem. We have a whole at 0, but we still have the 0 in the denominator. And so it's actually both, it's in the denominator, so we're going to include this in what it cannot equal for really both of those reasons. It cannot be where a whole is, and it cannot be in the denominator. So no matter how you look at it, x cannot equal 0 for whichever reason you like. X cannot also equal the negative 4/3. But because this is allowed, it is allowed to equal 0. This, of course, gets wiped out. It can't equal 0 and not equal 0. So it is allowed to equal positive and negative radical 2. If you need to figure out what the square root of radical 2 is, just put it in the calculator. It's right around negative 1.4, so that is the smallest number. It is closed because it is allowed to be that number. Then the next number is negative 1.3, which is negative 4/3. This one is open because it's not allowed to be that. Then we get to the 0. We've already talked about how it's not allowed to be 0. And then we have radical 2. And it is allowed to be radical 2. So we need to find a place to test. I'm going to test x equals 1. And we're going to plug that back into the original problem. Remember, it's not 0, so you're going to have numbers. So now we have 2 minus 4 on top of 3 plus 4. Is that greater than or equal to 0? And this is negative 2 over 7. So no, this is a no. So then our answers are over here. So yes, yes in here, no, yes. So again, interval notation, negative infinity to negative radical 2, bracket. Parentheses, negative 4/3 to 0, and then the bracket on the radical 2 to infinity. Now in this last part, remember you'll have your calculator, so you'll be able to draw the graph. You have your x, or your vertical asymptotes rather, are at x equals negative 5 and x equals 1. Your asymptotes have to be on the graph. So we've got an asymptote here and here. For your horizontal asymptote, remember this is the one that's a little bit hard to see on the calculator. You take your power on the top, which we don't have 1, but we have x squared on the bottom. So basically it's 1 over x squared. Anytime the degree is higher on the bottom, this turns into a 0. So we have y equals 0. So I'd be careful with paying attention to what it looks like before you draw the graph. So when you look at this, you can find the y-intercept if you'd like, or you can just look at the calculator. It's a little bit less than 1. This section in here does use the asymptote. So like this asymptote, you can't see it on here, but it is here. And then we also are going to have the other branches here and here. Now the question for number 18 is based on the correctness of your graph. So we are approaching negative 5, which is this line right here, from the left. So if we come at this thing from the left, we can see that the arrow goes to negative infinity. And so the correct answer would be to use the name of the function approaches negative infinity. And you are going to have to write one of these from the picture. Do your best to approximate what you think the asymptotes are. It looks to me like the asymptote's right here. So this is at y equals 3, so that's up 3. And it looks like this one is right here at 1. I would say x equals 1. So the left and right is going to move, sorry, it's going to be on the bottom because it moves left or right. So we wanted to call this x plus 1, right? Because if we get x equals negative 1, we want to make a factor out of that. This is supposed to say equals negative 1. So in order to make a factor out of it, you want to do the opposite. To move it up 3, I'd put it out here. Now, if you pay attention, this is upper left and lower right. That's not parent function. Parent function is this way, so it is got a reflection in it, so I would put a negative 1 in the numerator. Of course, this would be very easy to check. You just put it in the calculator and see if it looks like the picture. Good luck on the test tomorrow.